Hello, everyone. Thanks for joining us. We are starting our fifth episode of our interview series with Sorokel, and this is actually our first official podcast episode. So we will have also an audio-only version for this interview. Today, I'm joined by Brooklyn Zelenka, who is famous in certain communities, among other achievements, for writing some really cool Haskell fan fiction. And as far as I understand, she describes herself as a PLT enthusiast. And this is, and also Brooklyn is known to be working always on the kind of edge between different disciplines. So we're kind of trying to be on brand and inviting multidisciplinary people to our podcast. So I hope that I didn't mess up the introduction, Brooklyn. And I would actually just really start with asking you about how did you end up pushing buttons to make computers do stuff? As far as I understand, you started your career not as a coder necessarily.
Yeah, absolutely. First off, thank you so much for having me here and for the nice introduction. And yeah, you're right. I didn't start off as a coder. I initially was studying music theory and composition, and did a little bit of that. Did some film scoring, things like that, for very small, independent things. But hard way to make a living. Because I was in music, I was also doing a lot of the concert posters for my, the other students in school. So I ended up with some Photoshop Illustrator skills, worked as a graphic designer for a little bit, which, there's a lot more demand for than a classical composer. And worked a bunch of random odd jobs, ended up in a startup, and they said, hey, do you think you could learn a bit of front-end development, because we wear a lot of hats. You're a designer, you could maybe do some of that stuff. And they sent me over the weekend with a couple books, and I came back on Monday, and they're like, you seem better at this than you are at the graphic design. Like, could you just keep programming? So I did that. At the time, we were using this is before Node was really the clear winner. So we're using a JVM based backend that would let you mix and match all the different JVM languages, and this company definitely was mixing all of them. So I had to pick up a bunch of languages really quickly if I wanted to interact with the backend. So Groovy, JRuby, Clojure, a whole bunch, and found that I really liked it, and so got really into, as I like to say, collecting programming languages, getting really into PLT, and sort of the rest is history, I guess.
Before we start talking about PLT at large and maybe in some particular details about stuff, I would also like to ask you about the following. Well, right now you are a CTO, right? So which is a leadership position essentially. So I think that it will be very interesting for our viewers about your path to technical leadership, and given that, as far as I know, you managed to get into technical leadership reasonably quickly, perhaps what are the parts of your background prior to that contributed to this?
Yeah, absolutely. So there's two parts to it, I guess, really. One is I ended up doing a lot of management in places that are just not related to tech at all. My first job, through high school and university was at a restaurant, right, in the kitchen. And so learning to, as you work up through the ranks, learning to manage there, which is a very, I wouldn't recommend, restaurant internal management practices. It's mostly screaming, but learning from those things of what not to do, really, working odd jobs in, say, retail, and ending up really quickly in management there as well. My co-founder, Boris, often talks about people who have the common sense gene turned on. And so I think mostly I had some degree of common sense, would look at something and go, that doesn't seem right. Let's fix it. Let's get everybody aligned. Let's make sure everybody's unblocked, right? And not just have the thing be broken forever. And so you end up just, over the years, developing some experience with that. And I think that then carries over into other fields, right? Because it's a interpersonal skills portion. The other part from the purely technical leadership side is, so I'd worked at this small startup. I'd done some consulting on my own and built up, a skill set and a bunch of languages, which unintentionally, I think, had some like proof by intimidation of, I would talk to somebody and be like, oh, it's like in whatever, it's like in Clojure, it's like in Haskell, you kind of do it like this. People went, oh, she must really know what she's talking about. But at the time I have 2 years of experience. So you end up getting, thrown into leadership positions or running teams, more quickly from the purely technical angle as well.
Yeah, this is kind of already a little bit answers the question that I have as a follow-up, which is not like normal path of getting there is to go to a university, right? To study computer science for a while, and then like around third year or something to figure out which branch interests you the most, and then basically kind of become a specialist, right? Like classically trained specialist, and then kind of work like human skills, social skills afterwards. But of course, there are like big advantages of the classical approach as well, because this way people allocate a time where they more or less are dedicated to studying computer science related subjects. So what? Maybe you can share some, I don't know, organizational tips and tricks. How did you manage to to persevere, in the world full of distractions, and keep learning and yeah. So that's the question.
Yeah. So yeah, I mean it's true. My background is maybe to say messy at best. What I've noticed from people who went the classical route is they've been exposed to things that they may not have had interest in at the time, right? So they're forced to take a compiler's class, let's say, right? People that are self-taught can kind of wander around and explore the things that are interesting to them. I have the both advantage and disadvantage of everything's interesting to me. So I was doing this in my, I guess, early to mid 20s, and was literally just working 17 hours a day, 7 days a week, right? And just reading books, writing code, looking at other people's code, getting into older books, right? And all of this stuff. And that's really been consistent throughout my career, is just reading, learning, talking to people, going to conferences, picking people's brains, and feeling like every time I feel like I've hit a plateau, trying to find some other new area that might be of interest in which to grow. And that often takes me into these, as you mentioned before, sort of the boundaries between different areas, because I'll be reading a book on, whatever, compiler design and distributed systems, and going, well, could I apply compiler optimization to distributed computation? The answer is, yes, right? And oftentimes other people have already done that, and I'm reinventing the wheel, which in a university setting, your professor would say, you're reinventing the wheel, go look at this paper, right? Whereas for me, or other self-taught people, it's more of a random walk. But you can end up in a place where if you're passionate about it, right? It feels easy because it's also a hobby, right? But where you've gone really deep into some areas that other people may not have, because it's not this received curriculum, right? So it has advantages and disadvantages. I also saw this in, back in music school, because I was primarily self-taught prior to going to university. And then I was getting a rigorous classical training. And it was the same sort of thing of, when I was self-taught, I didn't know that this was supposed to be a very difficult piece to learn, let's say. And then I go to, audition and they say, wow, you're playing Prokofiev or whatever, right? And then getting the really rigorous, like, no, these are the exercises you need to do them in this order, right? Listen to these records and so on was also helpful. So I think that they're just different, but you have to have a lot of self-discipline to do the self-teaching route.
Yeah. Yeah, and for sure, exercises are very important either way. I think you will agree with me. And yeah, I wanted to say to kind of add to your point about how students are normally very fascinated about the curriculum. I think that one of the most important things they teach in computer science universities is actually stuff related to technical writing and code styling, etc. And the whole notion of, you write the code once and then it's read like thousands, if you're lucky, hundreds of thousands times. Yeah, so you have to write it for the reader, not for yourself or for the machine. And me included, I lasted in the university long enough to have this class, and I know no one who is like excited about this stuff in the uni, which kind of creates like this backlash effect, right? Because like then when these people graduate and they start writing code, and they kind of have this repulsion towards thinking about technical writing and whatnot, we have some problems from that. All right. So actually, you mentioned this one very interesting thing when you said that you were reading old books and old literature about computer science, which perhaps, again, already is a start of my other follow-up question, which is normally when I personally observe people who are, let's say, non-coders or like non-primarily coders transitioning into being like complete, like mostly or full-time computer programmers. Their initial exposure to programming is in some sort of maybe scientific language, or maybe some sort of like C-like language, or a scripting language like PHP or Lua or something like that. I don't know if Lua is a thing anymore, but you know what I mean. And what I find as a very frequent pattern is that people who have this career path kind of tend to stay within this kind of boundaries. Maybe they will learn like C-like language and a Python, or they will learn like Java and Kotlin, but it tends to be very justifiably limited their scope. And I think you are well for sure one of the most polyglot developers that I'm aware of, or that I know. Yeah, I guess aside from the fact that the JVM had many front ends, what's your secret to never stopping?
Yeah, so I think a big part of it early on was imposter syndrome, and just saying, everybody else obviously knows how to write Ruby. I need to learn how to write Ruby. And then, oh, there's this Python thing. Oh, they actually look kind of similar. Oh, what are the differences, right? And kind of finding that I liked learning about those things, starting from just, the absolute surface, and then, discovering, oh, okay, there's, these families of languages, and how are they different? Can I, both to deepen my understanding on things, but also just, for pure interest, is it possible to express object-oriented style in standard ML, right? Or whatever, right? Which has ended up being a bit of a theme, I think, in my career, is this remixing of ideas. So yeah, on the polyglot side, I mean, early on, I was writing mostly JS on the front end, PHP, and then JVM languages. Did a whole bunch of PHP as consulting, worked as a Rubyist for a few years. I was also running because I found myself drawn to FP just very quickly as something that seemed to make sense, that felt rigorous, that I enjoyed the aesthetics of, right? And Clojure being one of my first languages, I think really, I fell in love with Lisps, and that then, they would mention, ML. And so I went and would look at, standard ML or Haskell or OCaml, right? I ended up running the overarching unified functional programming meetup here in Vancouver. And a lot of people were coming in who wanted to learn about, that had no exposure. They were just told functional programming is interesting, right? And so I would have to meet them where they were at. It's like, okay, great, you're writing Python all day and you want to learn what a monad is. Let's write a monad in Python and just see what that looks like, right? And so part of it is this learning by teaching approach, and having to be able to express to people that, I was really the advocate for FP, and I was trying to get other people into it. And that meant that I put more of a burden on the teaching side of, okay, well, let's meet you where you're at. I'm going to go and learn a little bit of whatever the language is and try to get something closer to where they're coming from.
Yeah, that's really cool. And this is one of my favorite quotes, that in order to really learn something, you have to first teach it. So that's also very, very relatable. But it's kind of true, right? But also at the same time, to teach someone how to write a monad in Python, you kind of have to understand enough about monads. And I genuinely, it's hard for us, I guess, to look back to us being confused about this concept and kind of pinpoint exactly what was the issue there, which is something I'm trying my best myself to keep the beginner's mind attitude. But I know for sure that for me, like, these concepts, I guess, that go hand in hand with like stuff like parametric polymorphism and okay, type variables, maybe it's kind of understandable, but like the underlying manifold of concepts perhaps wasn't too understandable for me. And I know for sure that for me it was like a huge gap to get into this parts of ML like languages. So I don't know if you have the same experience. What were your like big roadblocks in understanding FP concepts and advanced FP concepts as well?
Yeah. So I found standard ML very natural. I had picked up, I can't even remember, this was so long ago, but I picked up a couple like classic FP books from the 80s, I think, that were written in SML, and really enjoyed it, but it's not doing, a lot of the a lot of the techniques that people get hung up on today didn't even exist, right? So when I moved into trying to write actual code in, say, Haskell, right? I remember bouncing off of applicatives and monads in particular, or even, say, traversable things like this a few times, and being able to remember perfectly well how to use it, right? So I do notation, and here's the DSL that I'm using, and that's great. And then looking at the theory and be like, okay, the theory makes sense, and not being able to reconcile the two, like they didn't seem to match each other. And you're right that once we've gotten over that hump, right, it's immediately everything makes sense, and it seems obvious, and so it suddenly is hard to teach, right? Other than having empathy for the person who's experiencing this, right? And I've seen this a few times now, where we have a Haskell backend at my company FISSION, and we'll bring somebody in who's never seen Haskell before, and we'll try to teach them whatever the concept is, and it's hard, and then they get it. And then it's like, well, why was this ever confusing in the first place? And they are in the same spot of it's hard to teach it again, because now they have this framework that works in their brain, right? The one that really did, that helped for me on this was, I can't remember his name, but there was one of the main people behind Link, LINQ, the database language, did a video explaining monads, right? And just walked it through really simply. And it's like, it's nothing other than this, right? There's no other magic happening. And for me, that was like the click of, right, the theory portion and the practice portion are actually, the same thing, and I need to stop looking for there's some extra magic, because I'm so used to there being extra magic in languages to support these features, right?
Yeah, for sure. And the video, we will put it in the description and notes. Yeah, it was very important for me as well. I still remember the first time I've seen it. It was at work. I was doing some banking in C#, and we were using Link gladly. It was pretty cool. And I mean, it is a cool technology. And I was just searching for some materials about Link, and I was already like kind of putting, like Haskell was basically with me throughout my career in some capacity. So I kind of had like Haskell learning on the back burner back then, and then I've seen this video and I was like, oh, I should get back to that Haskell thing. It's really really cool. Yeah, in general, it also obviously translates to F# to a reasonable degree. I'm pretty sure that these days the whole .NET infrastructure is even better than what 10 years ago. So yeah, I mean, I think that this is also kind of a nice suggestion for people. Like if you have, for example, just like you had, right, JVM code base with a lot of imperative code, but you also had some Lisp, right? So like same way, if you have .NET code, like out of work hours, you can also experiment a little bit with F# and maybe something will click, and you'll also then become a polyglot developer. So I wonder, you mentioned Fission and you mentioned onboarding into Haskell code bases. So does it actually help to have authored like Witchcraft, for example, and like monads in Python, etc., to like somehow allow people to conceptualize some stuff easier? And yeah, for those viewers who are not, or listeners who are not familiar with what Witchcraft is, maybe it's time to introduce it briefly.
Sure, absolutely. So maybe the best way is to describe how Witchcraft came to be, because that probably gives a lot of the context of even what it is, right? So I was at the Vancouver Functional Programming Meetup, and had Vancouver at the time, I think probably still, had a lot of Rubyists. And everyone was getting, this is in the era where everyone was getting frustrated with the lack of concurrency support built into the language. So a lot of people were looking around, and Elixir was, kind of has Ruby-ish aesthetics. It's a very, very different language, but, comes from a lot of Rubyists working on it, from the Rails core team and whatnot. And so people were coming in wanting to know two things, right? I want to know all of these scary abstractions that I've heard things about. I want to get over that fear, and I want to learn Elixir. So they were coming in mostly from Ruby, and I had to teach them at the same time Elixir and functions applicative monad, right? So I thought, well, we started with okay, well, let's just do some live to show we have things that are functor like in Elixir, but it's not quite the same. So in Elixir, you have a enum package, and it always outputs a list at the end. And we want to get back to the same data type that we had. So wrote a functor instance and went, okay, well, this is kind of interesting. What if I turn this into a larger project? Well, we're missing a few things in Elixir. All of the really classic FP stuff, like partial functions, and they don't have an identity function, things like this, right? So over the course of, I think, a weekend, I wrote Quark, which is like the small pieces that you would put together to compose and decompose functions in Elixir, and that was really gave several people aha moments. And then, okay, well, maybe I should then flesh out this functor in Elixir idea, and then ended up doing quite a lot. Like there's comonads in there, there's all kinds of stuff, right? Semigroups and all these things. Implemented do notation directly in Elixir as macros, and it reads actually like Elixir doesn't have a type system, right? But it reads pretty close. So you do have to tell it, I'm in this context, right, off the top. But it's almost identical to reading Haskell code once you're inside. And also went pretty far with that, abusing the macro system so that we could do some property-based checking at compile time, things like that. They have something like a type class, right, called a protocol, but it doesn't, you can never inherit from another one, so you can't have these, towers of abstraction. So used macros again to implement checking that the instance has or that the type has an instance of the, if you're an applicative and you set a functor, so it'll actually go and check that at compile time. So went relatively far with that. So that's Witchcraft. It ended up getting used like actually in production in a few places. Mainly people use it for error handling because they, people might be coming from Haskell and they want that, that cleaner error handling style. I'm told that a few banks are using it, which is always scary to hear. Some web projects as well, because they can, define their own classes and towers of abstraction, things like this, right? Which is always nice to hear from people. In terms of onboarding folks into FP by using this sort of thing, I've found in the past couple of years, last 5 years in particular, functional idioms have become much more widespread. So people are mainly coming in having already seen TypeScript in particular, right, at minimum as a baseline. So at one point, I started writing a Haskell for TypeScript devs Git book. And just sort of like, as I was teaching things, if there was something where I would, write a comparison, here's how it would look in TypeScript, here's how it looks in Haskell, right, for somebody, and then I would just, stick it in that guide. That repo was getting more stars than like almost anything else at the time, like in terms of, pace. So there's definitely an appetite for learning these things. I didn't have the time to really flesh it out, but that's something that might be, I'm the CTO at a scrappy startup, right? So I have like no time for such a project, but if somebody ever wanted to pick that up, I think that'd be really helpful for a lot of people. So doing these translations seems to be really, really useful.
Yeah, that's really interesting. It's kind of what we're doing in Siracle, because obviously in Siracle we have a bunch of Haskell developers, and we are Haskell developers since TypeScript, more or less since TypeScript was like the thing, right? So for us, we constantly are producing materials like TypeScript for Haskell programmers, right? So
right.
it would actually be interesting to see if we can maybe contribute to each other's work, because obviously it's kind of bijective often, right?
Yeah.
A little like more technical question I would like to ask. You mentioned that you used the macros in Witchcraft to basically be able to express constraints, correct?
Yeah.
So these are constraints between like different type classes, right? So you can make a type class hierarchy using these constraints, right?
Yeah. Yeah. So
yeah, go ahead.
Sorry.
Yeah. Well, I mean, I wanted to maybe for you to talk a little bit more about that, because it's not obvious why it sounds a little like science fiction, but it's to me it's pretty impressive. So I'm interested in like how, more or less, kind of little technical details about how you achieved it. And also I'm interested, like you said, that Elixir is not typed, but in reality, like many people are using Dialyzer very aggressively. And there are, of course, a lot of gotchas, like the maximum depth of success typing in Dialyzer, for example, which is which if we want to write like recursive types, obviously it messes things up and is not producing the best results. But also I think that for many people who would want to have a look at Witchcraft, they would also want to look at the Dialyzer. And if you could say a couple of words about what's the interplay right now, how it's going to be in the future,
right.
What would you like it to be, etc.?
For sure, yeah. So let's start with type classes. Um, it actually ends up not being too difficult to implement. It's mostly just thinking outside the box. So the end state, it ends up producing just a bunch of protocol instances, which is just a language level feature, right? While the macro is running, it's not that it's, people generally think that a macro goes from AST to AST as a pure function. And actually in some languages that's true, but in the case of Elixir, you can do kind of whatever. You can do side effects, assertions, all of these things. Run arbitrary code. And so essentially it looks at, okay, I've compiled so far. I'm waiting to see these modules having been built. And when they are, is there a protocol instance, which is a built-in feature in the standard library? Is there a protocol instance for this type? And if there isn't, then it throws an error, right? With a nice message and all of that stuff. The DSL for doing these is, so you, instead of having def protocol and def impl, I think, for implementation, you have def class and def inst for instance, which then desugars into just a regular protocol instance, right? But we'll run these checks as the macro is running, right?
Yeah, and a little note, I guess, for our viewers is very mind-blowing thing, perhaps for some, is that as far as I understand, you only put def insts outside of the module that you actually just defined. Is that correct?
Yeah.
So that they, yeah. So this is a really cool thing, right? So you have this module, you're like writing a thing that should conform to some type class, but then you don't interact with like Witchcraft type class system inside the module that you're writing. You kind of go step out, you write your def insts, and then as compiler compiles your stuff, I assume because the module AST4 module is already in the context of compiler at the moment when it reads def inst, it will be able to basically do all the checks that Brooklyn just described. Sorry for interruption, but I think that it's a like really cool thing that people get impressed with when they look at like Elixir. Go ahead, sorry.
Okay, great. Yeah, so exactly. And then I was looking at, it's like, well, there's no built-in type system. What if we added essentially some limited prop checking to make sure that there was, you had reasonable instances? And that's probably the most controversial part of this, right? That's maybe a step too far, because now your compilation, which normally in Elixir moves very, very quickly, is now getting stuck running, 100 checks on each of these things, including when you've imported a library. So I have this very long-running PR, we'll say, where I keep trying to get back to it, and then I look at it for 10 minutes, try to get back in context, and then I'm run out of time. But essentially, to be able to either disable those checks at compile time or turn them into test instances as instead. But it only needs to run them today the first time you compile the module, right? So when you install the package, it takes a bit of time, and then after that, it's very quick again, which is good. And then that was. Oh, right, yeah. And then the other piece, just in case there's somebody out there listening who wants to do these things, a lot of people in Elixir, you can quote some code and turn it into AST, right? And so it feels very natural to be able to write what looks like regular code and then essentially use them as templates. I gave up on that essentially immediately because when you're trying to do these more complex things where you're really generating transforms between from AST to AST, I just work directly in the AST in the tuples, and it just ends up being a lot easier to reason about, even though there's this initial step of, okay, I have to actually understand how the syntax works underneath. And sorry, remind me again, because I just went on a giant rant about the
Yeah.
internals. What was the second part of the question?
Yeah, the other bit was how does it relate to Dialyzer? Because people are
Mm.
incentivized to like use them together or try to.
Yes, yeah. So Dialyzer is great. It definitely has some. For people that don't know what it is, it's a static analysis engine. It does a bunch of things like case checking, heavy exhaustiveness checking, things like this, and then you can also provide type specs, which is like a lightweight, um, optional, and by optional I mean like not required type declaration for all of your functions, um, and run it through Dialyzer, which will then tell you, hey, you've got a broken thing here and here. Um, I've found it's possible to lie to Dialyzer and it'll accept things sometimes. So it's not a hard and fast type checker like you get in ML languages, right? Um, Part of the Witchcraft suite, so I ended up breaking out into separate packages so that people could use, only the bits that they cared about. One of them is algae, which is short for algebraic data types. Elixir doesn't have, in particular, some types. So it's both provides a DSL for like a macro for building product types that have their type specs in line. So it looks a little bit more like a Haskell record, right? And that'll also generate the type spec. And then also for some type, which is something that's just not natively, doesn't exist in the language, will produce submodules that have their own structs, even if it's a single field struct or has no fields in it, right? It's really just tags at that point. And then produces a type spec that can represent, okay, here's the sum that this represents. The actual typing out of that, or the expansion of that macro, is very, very noisy, right? So you end up with a lot of extra detail, submodules, type specs, and having to balance all of that in your head. So this ends up being a really nice way of expressing this idea, which then plugs in very well into Dialyzer, because at the end of the day, you now have a regular Dialyzer type spec that you can run through it, and they do
Yeah,
have
and as far as I
a vertical
understand,
bar pipe. Yeah.
yeah, as far as I understand it, also, if for example, if you have like result or either with left and right,
Mm-hmm.
then you can plug you can type spec in your functions that you're writing using Witchcraft, like both either.t and
Mm-hmm.
left.t and right.t, and if you write, like, it will basically Dialyzer will complain if you put right into left,
Mm-hmm.
and will be happy if you type out something as either. It will accept either left or right. Is
Yes.
that correct? Yeah. So that's
Yeah.
also pretty sweet.
So you get one layer extra that you wouldn't see in, say, Haskell, right? Where you can say this is a right and not a left, right? And you can type that because Stylizer doesn't understand really, right? Unless you refuse to export one of the sides, right? Which is actually, perhaps an advantage, right? This is, more like an open union, sort of, right? Um, but yeah, exactly. So it ends up bringing this feature that we don't really have, and because Elixir has this, it's really, in a lot of ways, it's a Lisp with a different syntax, right? So you can extend the language in these ways. It's really super expressive, that you can then bring in these new patterns and express them.
Oh, yeah, for sure. And I guess my final question about the technical details before we step out, like in the stack trace or something, is so I might be too stupid, but I didn't figure out a way how to express how to convince Dialyzer that what what algae spits out
Mm-hmm.
can be parameterized with a type variable. So like, is there a way to tell like Dialyzer, oh, this is like either of binary and this is either of int?
Yeah, so we haven't built that in yet. at some point you start looking at it being like, how far am I going to go, right? There have been a couple times I've heard from a few people that have a few companies actually that have been exploring adding a gradual type system to Elixir, like into the base language. There's a couple typed languages for the underlying virtual machine, the Beam, but people want it specifically in Elixir because that's the one that has most of the mind share, right? And this would have been a few years ago the last time I heard about such an effort, and nothing has surfaced yet. So I'm not sure what the state of that is. It would be conceptually possible to do in macros with the existing system, right? There's where you would essentially copy the type spec and then insert in where there's the any's right now. You'd insert in the thing that you're actually looking for. It's doable. I'm not sure how, I guess on two fronts. One, how many people would actually use it in Elixir, right? And then two, it's at that point, it's like, well, should we just go down a layer and add this into the language directly, or give it some better support rather than trying to do everything directly in a library? So,
right. Yeah, and again, for people who might not be aware, Dialyzer was not designed together with Erlang, which is the parent language for Elixir. It was later designed and developed by a research group in Uppsala University, led by Konstantinos Sagonas, I think. I always confuse his first name. And in my opinion, it's a wonderful tool, but of course it's rough around edges and edge cases. And this is one of those. It's very encouraging to hear that it's possible, that you see it's possible. And actually, now that you described the idea for implementation, I think I might have some pet project to do. Because I would for sure make use of it, because it kind of feels a little weird, right? You have all this very tight, very nice ways to express which function in your code takes what type, but then the moment you want to kind of handle errors, you kind of go away into result or either, and then you're like, oh, now I lose all this information. It's kind of a little weird, and and the depth of one is something Dialyzer can cope with. So it's I think that this would be very nice to go just one layer deeper, at least in my opinion.
Yeah, absolutely. And actually on this topic, I've mentioned now maybe a couple times that there's a few things in Witchcraft that I would just love to see get built. But I've gone the startup route, which means that essentially all my free time gets sucked up by the startup, right? If anybody is looking for a side project, doesn't have to be maintaining the entire thing, but is looking for a side project, wants to pick up some issues, wants to contribute back. I've set it up now in its own organization, happy to give people permissions, right? There's a couple of people that have been poking around, doing some maintenance. Mostly I've been feeling guilty the past couple of years of being like, I just need to get back there and fix a couple things. But at the end of the day, it's a community project. So if anybody's interested, please drop me a line, and I'm sure.
It works actually, so you shouldn't feel guilty. And also, like you were describing the path of you creating Witchcraft, and I'm kind of looking back to my practice with Elixir, and I understand that, okay, I always would carry this module that I call DIN hacks, like dynamic hacks, from project to project, which had like fmap, which had constant, which had a ID, everything, you need to like, but obviously it was not pushed far enough for it to be a library. And when I learned about Witchcraft, I was like, wow, that can deprecate DIN hacks. But I mean, I still have both Witchcraft and DIN hacks, because sometimes I don't want to think too hard.
Right.
Speaking of thinking too hard, so I see that I think in Witchcraft repository you use term deep functional programming, right? And I really I think I understand it. But yeah, I would like you I would like you to explain it in your own words, and maybe, yeah, and I'll have some follow-up questions about that notion.
Yeah. So it's, I mean, really a ad hoc phrase, right? I was looking for, okay, well, FP, there's lots of different techniques. There's several families of languages underneath, right? We've been talking here, Haskell and Elixir feel very different, right? At a high level, right? Um, Even from the point of view, Elixir wasn't designed to be a pure functional programming language. It was designed to solve problems at Ericsson, right? So they happens to end up in with a lot of FP flavor, right? But it's certainly not a pure language. In fact, the whole VM is really oriented around side effects, right? So deep functional programming is sort of a placeholder because I don't have a better term for, using particular abstractions, going really deep with, calling something like, these are algebraic languages, A, scares people off, and B, there's lots of things that are algebraic outside of algebraic data types, right? So
like
it's,
SQL databases.
yeah, sure, exactly. And so it's really trying to just capture this idea of the part that most people think is scary, right? Is these deep techniques, where it's not the first thing that you'll learn when doing FP. I think it's I think it's the Fantasyland Institute, the people that used to run, or maybe they still do, run LambdaConf, used to have a list of, here's beginner, intermediate, and advanced FP concepts. And, I'd say, yeah, that's like roughly the trajectory for a lot of people. So this is more the like deep FP is more the intermediate and beyond area.
Right. Okay. So would you say that, like, you mentioned how over the past 5 years you noticed like that this concept from like higher order functions, I guess, and etc. Become more mainstream. So would you say that kind of the waterline, where would you put the waterline for the deep functional programming compared to the sinking ship of imperative programming? I guess that's my question.
Yeah. So I think it partly depends on, I mean, programming is so broad, right? There's so many people. It partly depends on the particular subculture, right? But looking around at, there's a lot of packages in the Node ecosystem, right, or in NPM that implement these things. There are people that would like to write OCaml or Haskell or whatever that want to bring some of these concepts back in. There's a version of these, as I like to joke about them, Haskell fan fiction libraries in essentially every language now, right? So a lot of people are getting exposed to these ideas, right? Absolutely true. We're also seeing them start to end up in other places. Ink and Switch, which is a industrial research lab, has sort of repurposed bidirectional lenses for doing schema management, right, between arbitrary schemas. It's a little bit, they're using a slight variation from, say, the lens library, but still it's like this basic idea. In Swift, I saw somebody had ported parser combinators, right, because it ends up being a really nice way of working once you understand them, right? Like there's a learning curve, but once you understand them, it ends up being a really nice way of working. So more people are getting exposed to these things. And when you have a background already in something like just, the absolute classics, right? Map, filter, reduce, or understanding that you can build your own higher order functions, or that there's relationships between different things that are more principled, and put that in big scare quotes, right? um, there's at least now a foothold and a jumping off point, and not having to go to the gang of four patterns and say, well, it's kind of like a, facade or something like that, right? And saying, here's the actual underlying idea. It's a little bit like these other things you've already been exposed to, is super helpful. So even in both the functional programming group here, which I should probably also specify, it sounds like it's mostly, Brooke shows up and teaches a bunch of people about FP. There, we were running, pre-pandemic, we're running various language learning groups. There's, Haskell learning group, we had a closure learning group, things like that. And then, events where people could come and just present, a topic or an idea that they're working on. So there was pretty much, it was really intended to be this pipeline where you could take people from absolute beginner all the way through to pretty advanced, right? With a lot of these things. And it got, in the past few years, again, it's hard to say in the past 2 years in particular, right? But the past several years, much, much easier, just because people had seen this stuff before. There's more learning resources, there's more books. Typically, people will have taken a run at this kind of thing before trying them out. So at one point I was consulting at a company that was doing a lot of TypeScript, and they would run into problems. I'd say, oh, well, there's a solution for that, and here it is. Like, oh, wow, that looks really elegant. I'm like, I know, it's a monad, right? It's a scary thing that you've been, running away from. And here's an actual use case, and now you have a practical application of it because you're working in a typed language with higher order functions that you're trying to kind of, move in this direction. You don't have as much help from the compiler to do it, but you can, right? So yeah, it's become just way easier. And I like the metaphor you're using of, there's this sinking ship and then this, rising water line. As people get exposed to things like, I think Rust is going to be huge in the next, couple of years. And it doesn't have, exact feature for feature from, say, Haskell, but there is a lot of higher order function stuff happening there, right? So, and people getting exposed to types as well. So I think it's only going to become easier. And this, Simon Peyton-Jones says it's not just about, the idea for Haskell isn't that it should be the number one language. It should influence all of the other languages, hopefully, right? And I think it's been tremendously successful at that. When you look at all, both the fan fiction and then the language features that we're seeing in, very mainstream languages today.
Oh yeah, and then Haskell isn't stopping with the linear types, with dependent types.
Yeah.
I mean, with Rust, it's an interesting observation, but I think that Rust is to me, writing in Rust is kind of like living in Charut jail in a way, because
Yep.
like in Haskell, when you have like linear types, you are the person who says, okay, this part of my code will be like affine or linear. And in Rust, it's like you are dropped in this affine environment, and then you kind of have to cope with it somehow, which is great for the design goals of the language. But I'm very kind of cautious to recommend Rust as like first exposure to functional programming necessarily, because there's like so much more stuff to understand.
Yep.
Yeah, but certainly implement like, I don't know how you. By the way, maybe this is a question to you. Maybe you can tell us how easy it is to like do PLT from ground up. You know how like back in 2003-05 we had like Linux from scratch project, right? So I wonder if we have something like PLT from scratch these days. But actually, maybe. Telling students to implement their own tiny Rust, that would be a very interesting study group project. But what do you think about how feasible it is, how easy it is for people these days to implement like a programming language, and how would you go about making a study group, let's say, for like intermediate students to do that?
Yeah. So, it depends on the language that you're trying to do. Somewhat few years ago was writing a Haskell from scratch, I think, which is an interesting read. Writing, a toy language is not a super difficult task, right? Once you understand the basic concepts, it's actually something that I would give people as an interview question often, as something that assuming that they'd never seen it before, right? Because when interviewing, I want to see how their brain works with just out of left field questions. Here's a really simple Turing complete language. It has six symbols or something. Write a small compiler for this. You don't have to get to the very end of it. Just like, I want to see the thought process. And honestly, a lot of people would get to the end, and it would not take them long, right? Going further and implementing types and optimization and all of this stuff, I don't think it's an insurmountable task to teach, really, because all of these things have enough history that the concepts are quite clear, right? And you can go really as deep as you like and get into cost dynamics and all of this stuff. But a PLT from scratch, oh yeah, that sounds like a great project. Again, when I have time again, I would love to do something like that. Or if somebody wants to write that, I would love to be a reviewer on it, because that's just a super interesting project, right? The other one that I think is really useful, and that I've given a couple talks on now, is just getting people exposure to more idioms, right? So we've got imperative, OO, functional, and deductive languages like Prolog, for example, that people have just never seen, or APL, right? They've just never seen this before, and trying to break people out of, here's the patterns that you're used to, and into let's get a little bit more flexible and think about computation broadly, right? Is also very helpful, also for when evaluating languages and writing them as well, saying like, I'll take a little bit here from the from array programming, and I'll take a little bit from here from Lisp and so on.
Oh yeah, and for sure, allowing students or people in general to think about stuff in terms of computation also makes it easier for them to think about novel approaches in computation, such as like quantum computing, or my favorite topic is reversible computing, where instead of having hardware that just goes, that forgets about stuff, it keeps track of all the computation that happened historically in hardware, and then ecological computing maybe someday. And yeah, anyway, so yeah, these are fair points. I mean, PLT from scratch would be ideally, of course, when I'm thinking about how it would ideally be, it should be something like Lego, right? Something that what you said exactly, right? We have a lot of concepts that are well studied, well understood, and we wouldn't want to waste our time on re-implementing them for the 500th maybe time to get to the interesting bit. So perhaps some sort of Lego constructor framework to kind of that's a very smooth segue to that cryptocurrencies Web3 stuff that we should cover, I think, a little bit. Kind of like this. There was this project, one of the first proof of stake cryptocurrencies ever was a research cryptocurrency made in Scala or something, and it was built like a framework. So basically you could take it and you could change aspects of your consensus algorithm, or topologies it would work with, and a lot of that sort of stuff, without really tinkering with all the kind of boring bits blocks, block minting and block hashes, etc., storage, databases, compression. So yeah, something like that for PLT would be really cool. I wish there was as much money in PLT as in anyway, so yeah, let's talk about Web3 now. What is it actually? I'll give a little bit of a background. Okay, so I'm very active. Like I stopped. I can't tolerate Twitter anymore. I don't know why. I don't know. Maybe lost tolerance to toxicity or something. I don't know. But I switched to like Fediverse, Mastodon, and platforms like this. And basically, like 90% of my feed these days is people saying how like Bitcoin kills puppies or something, and how like Web3 is, BS, etc., etc., etc. And to be completely honest, many of actual arguments that are made in my feed on Mastodon, to me, look kind of appealing. It kind of and coming from cryptocurrency background, of course, I know how much of questionable substances are floating on the surface of this modern technologies. So. But I honestly, I don't quite understand what Web3 means. So yeah, if you can put it in a positive light, or repel the common arguments against it, that would be really nice.
So I agree with some of the negative comments about it. So let's get into a nuanced discussion here. Web3 is definitely broader than blockchains. We've been using the term for, so I entered the broad space in 2017, 2016, 2017, somewhere there. Working on it professionally, not just playing around with things on the side. I was was brought in to work at a fintech company that was doing stocks and bonds, securities on the blockchain, cross-border, all regulated. And they needed a programming language that was formally verifiable, but also legible to a lawyer, right? So a non-developer lawyer has to be able to read this thing, and it also had to be able to produce verifiably correct code, right? That would then run, and we would be able to plug in things like, here's the regulations in the US, here's the regulations in South Korea, and they have to, overlap. And then plus all the extra logic for the particular stock, let's say, right? As I sometimes like to say, the point that we got to was the unholy union of Prolog and COBOL, right? Because it was essentially a business language with constraints. So even going back then, we were using this term broadly of Web3, which was coined by somebody in the blockchain space. If you take a step back and look at the broader picture of what's happening as this potentially a generational shift, right? Because Web 3.0 used to be semantic web, right? So we'll see where these things go. The overarching idea is we're trying to return the web to its original founding principles. So when the W3C was created, they had 5 main values, right? Decentralization, non-discrimination, bottom-up design, universality, and consensus. Consensus in a different sense, right? Of people actually running things, not consensus as a distributed systems mechanism. But those all hold very strongly for this community of people that are working on things. So I say that's larger than blockchain. It also includes things like and I'm sure that we'll dive into a few of these in a moment, right? But what some people call distributed web or deep web, right? Where you can self-host data or have it be hosted in many places, and you can retrieve data by its hash. So a little bit like BitTorrent. In fact, BitTorrent probably fits under the broad category of Web3 as well. It just started before the term. Blockchains are in there. They are one tool of many as we're moving towards a world that has more, the entire web is a distributed system, but using more and more distributed systems techniques and developments and making things self-verifying, right? It's kind of the broad technical unifying theme, right? So, and having users be able to control their data rather than the big cloud providers. So I don't know about you, but I don't want to see Amazon, Microsoft, and Google own all of infrastructure for all of the future, right? And there's some people, Cloudflare and Fastly and a few others, Fly.io, that are working on, doing things at the edge, but it's a really difficult challenge to go up against the 10,000-pound gorilla, which is Amazon or AWS, who will just put in data centers wherever you are, right? And these technologies fundamentally say, okay, well, things don't live in one particular location. They're owned by the user. They can be completely local. They can be offline and continue to work. And we're not saying no to AWS. AWS could absolutely participate, but so could everyone else. I could use my excess computing resources to serve files or run computation or whatever. The big complaints, the two main complaints, I think, with blockchains in particular, are there's a lot of scams, which is true, and there's proof of work uses a horrendous amount of energy, which is also true, right? So huge number of scams. Yep, absolutely. There's lots of scams in the world broadly. This is unifying fintech with more distributed systems geeks, right? So you end up with this area that is really focused around today around money. There's more applications to this because really what it is global distributed consensus, right? It is a way of everyone getting on the same page about some piece of data, but that's not the only way to do these things, right? You might not need global, everyone's on the same page about what the state is, right? You might have a more granular thing that only two parties are doing, and now you don't need a blockchain at all. But yeah, scams exist. They're already regulated, right? Like Ponzi schemes are illegal, right? So those, and you need to be careful when buying anything online, really. It's just there's been so much upside for people in the past couple of years that they're heavily incentivized to make risky actions potentially, right? So that's the scary portion there. That absolutely needs to get taken care of. And if there's a market crash, maybe we can get back to building things again, right? Yeah. And proof of work. Yeah, and if there's any Bitcoin maximalists listening to this, they're really not going to like what I have to say here. Proof of work uses a lot of electricity, is actually not that secure, and most projects, except for Bitcoin, are moving off of it, right? So when I say it's less secure, I mean there's this flywheel where you make money from mining Bitcoin, and then you can use that to buy more graphics cards to mine more Bitcoin. And over time, this centralizes into a few providers, right? So you end up with, even though everybody can participate, you end up with a couple of really big providers that are really calling the shots about what's getting in, what isn't. So the other two systems, proof of stake, which is more of a voting system and uses social and economic systems instead of burning processor cycles to secure the network. It does still tend to lead to a handful of people owning most of the what's going to happen or not on the consensus mechanism, but it's actually, you can design that to be more equal. And then there's a bunch of effort going to things like proof of history, which is just using hashing, recursive hashing to see how far whoever has the highest hash wins, and then everybody can synchronize against that immediately because now they have the latest hash and we can just keep going, which is an interesting solution. So there's lots of people that are trying to make this way less energy intensive. So I think that that's a potential future. But again, without wanting to overfocus on blockchains and broadly digital scarcity, and we could have an entire podcast about that, I'm sure. Tools like IPFS or DATS or Secure Scuttlebutt SSB, let you are the early picks and shovels, right? This is all early stuff for liberating data from a particular location, having essentially a CDN that's based on who's looked at something recently, kind of like how BitTorrent works, in a collaborative setting. And you can extend this to all kinds of things, like why am I, if we're going to talk about electric usage, right? Why am I recomputing solutions to problems over and over again when somebody else has probably run that computation before in a lot of applications? What if we could post our sub-computations even, and then now we have a giant memoization table that we can start pulling data out of, right? And the more people that participate in such a network, the more efficient it gets, right? So this is all stuff that's really on the edge in every sense of the term, but that is very much under the umbrella of Web3 and where Web3 is trying to go.
Yeah, and also it's the global memoization table that you have mentioned is a little bit goes a little bit hand in hand, maybe pinky and pinky with reversible computing hardware, right? So it's it would be really sweet. I actually learned about reversible computing from obsessing, like perhaps overly obsessing over the fact that okay, I write normalized structures, be it text or be it like data structures or code or ASTs or something like that. And I have parsers from those to some expressions in memory. So if I only use normalized stuff and I'm okay with normalized stuff, why does my parser library not generate bijective functions straight away? Like, what's the problem? And yeah, I was reading a lot about this, and well, there are some problems, but yeah, this is how I learned about reversible computing. But certainly, if I put on, I don't know, IPFS saying, well, I parsed like this hash and got this result, and you can query me, and I'll tell you what were the inputs and outputs, and you can hopefully somehow verify that I'm not cheating you. Then yeah, that could be rather sweet. So basically, so I pose as a person who doesn't know anything about Web3. So, but I'm also, let's say, using verifiable credentials in my projects. Does it mean that I'm part of the movement?
Yeah, absolutely. So verifiable credentials are a W3C spec for asserting things about a person or an organization. So the really classic example is today.
Well, any subject really, like a table or whatever.
Yeah,
yeah,
absolutely. The really classic example today is, you want to go to a bar, you need to be 18 years of age or older, and you show them your driver's license. And on your driver's license is also your home address and a bunch of other information about you. So what this lets you do is the government can sign something that says this person is over 18, not even your age, just like literally this person is over 18. They have a private key that they can prove that they have some information that nobody else does, and now you have a verifiable credential that's signed by the government in this case. Which is actually something that in the province where Vancouver is, in British Columbia, the government here is already doing these things, right? So this is happening for sure. It's a useful thing, and when you think Web3 and governments together, people usually go, no, it's the weird hackers that are doing Bitcoin. It's like, no, the government's absolutely doing these things too. It is a system that is local first, so it doesn't have to go to a database necessarily. Some cases yes, some cases no. It's self-verifying, right? And is protecting more information about more of your personal information, which I think is something that we're, as a society, coming to realize is really important stuff, right? So yeah, absolutely. Verifiable credentials, decentralized identities, DIDs, which typically go together, are absolutely part of Web3 broadly. There's a lot of interesting work happening on both of these at the Decentralized Identity Foundation, DIF. And this is part of, I think, why people have a hard time with the term Web3 is the scams and the coins are the ones that are getting all of the media attention. And in the past couple of months in particular, it has shifted to mean more that, whereas it used to be a broader term. And I'm hoping we get back to the broader term because there's all of these other interesting things that have nothing to do with those other bits. We use DIDs pretty heavily at Fission to reverse, both to make apps work completely offline and to reverse the control. User creates a key pair in the browser. The Web Crypto API lets you have a non-exportable key. So nobody can take your key and run off with it. It's more secure, at least. And then they register with other services. So they'll register with, say, today, Fission's service to say, hey, please store my stuff, which is all encrypted, and the user has encrypted it, right? So it ends up being these both, verifiable things like verifiable credentials, which are a form of digital scarcity, right? We can say that this is an individual person, and I can verify it directly, and nobody else has that. And also the privacy and user control aspects are really core to Web3.
Oh yeah, yeah, and I asked about verifiable credentials for a good reason. As recently, I was trying to understand how are we doing authentication in 2021,
Mm-hmm.
well, 2020, whatever, and I was reading, we still have this identity providers, and I was like, what? Why? What does it even mean? For why someone is providing my identity to me? Like what? And I mean, if you think about, how people say, well, okay, we need to go passwordless and et cetera, et cetera, et cetera. I think that this all is irrelevant. What is relevant is, as you say, seeing who has to own which data. Like, my data has to be owned by me, and we have very dumb cryptographic primitives to allow me to do so. And the fact that they're very dumb is not a bug, it's a feature. When you said about government will sign the time over 18, and someone would ask like, why won't you use threshold signature? Well, I mean, because maybe my cryptographic suite doesn't implement threshold signatures, right? I'll just and this is so. And when I was researching this subject, I found out about DIDs, which I ended up not using. But I also found out about verifiable credentials, and I was like, well, wait a sec, this just makes sense, right? And you can implement this in one evening and deploy to your whatever startup, to your authentication system. Even I integrated it with this Ruby whatever, I don't remember the name. Yeah, so I mean, again, I don't know much about Web3, but it doesn't seem like Web3 people are evil. Look at Brooklyn. How can you say? Anyway.
Right? Yeah. That's what we want you to think.
Right. So yeah, let's wrap it up before we go to questions. Please tell us a little bit more about Fission, about what you're doing, anything you want to plug, anything you want to call our listeners to contribute to. The floor is yours.
Yeah, thanks. So yeah, absolutely. So Fission, my company, my startup, is a applied research company working on developing local first and user controlled applications that don't need things like Kubernetes to run. So everything happens directly on device, like at the client, in the browser, or in the native app. You can then, once you've solved those hard problems, right, you can then walk these things back up into an edge data center or into the cloud, and really anywhere. We're making all these things location independent, user controlled, encrypted at rest, right? So that as the service provider portion of the company, we don't even know what somebody is storing with us, and they could also store it with multiple people, and that's actually, or multiple providers, and that's fine, and that all works. And it's essentially, the idea is get rid of your backend. It's for those of you, since we've talked so much about Elixir here, if you've seen Phoenix Live View, it's almost like the direct inversion of that, where instead of everything happening on the server, it's now everything's happening on the client, and you can progressively sync the data in the background. Everything that we're working on is pretty cutting edge and pretty early, so we're definitely looking for people to try it out, find the things that don't work, and things that they might find surprising. So we're at fission.codes, and which has links to essentially everywhere, including our GitHub. And our Discord is fission.codes/Discord, and that'll get you an invite and the link directly. And the other thing that I want to plug is we're going to be starting up a distributed systems reading group. This is something that we've had a few people ask for, people that are either interested in learning about it at all, like as a complete beginner, or people that want to just have other people to geek out with. So we're not really sure what the level is going to be yet, but if you go to lu.ma/fission codes, there's the distributed systems reading group in there. And we're going to be looking at some classic papers to get started, and then maybe some more bleeding edge stuff in a month or two.
Awesome. I went there right away. I'll try my best to be first to sign up from our audience. Thank you very much. Okay, so let's go to questions. But before doing so, I would like to remind our listeners, and we have so many platforms now, so I need to wrap my head around what to say. But anyway, so put us into your RSS feed, put us into your like YouTube subscriptions list, whatever, because we're doing it for the audience. We're trying to invite cool people who are doing stuff in programming language theory, who are making cool libraries, who are just in general like whom we consider, or some of you who ask us to invite someone to consider to be like great thinkers of the modern time. And yeah, like if not for the audience of our podcast, we wouldn't be doing that. So show us some love, and I hope that you enjoyed this episode. So let's go to questions. Question number 1 is, what makes Haskell special compared to Rust?
So I think this is a comparison that's going to get drawn a lot over the next couple of years. I've been working more in Rust, especially as we're doing more things with WebAssembly. And it's sort of, like the WebAssembly language, really, at least in 2022. And yeah, there's some surface level things that feel very similar, right? Having a type system really, at all, doing a lot of things with, case statements and destructuring and all of that as a workflow, despite the syntax being very different, but and both of them having really, really good concurrency, right? So those are some of the similarities. Major differences, in Rust, you get mired in a lot of detail that you just maybe don't care about, right? Because it's a much lower level language. Haskell is garbage collected, for better or worse, and that means that you can be really, on a, not have to worry about as many of those factors. It's, I mentioned before, Rust has some, higher order function, capabilities. That's a little bit of a lie, right? It has, it doesn't have like full blown anonymous functions that you can just, plug in whatever, right? Haskell has more functional, traditional functional capabilities. And has more facility for abstraction. So actually, I don't know if Rust has landed higher kind of types yet, but I know that they're at minimum working on it. And Haskell just has 30 years of history, and Rust doesn't. So there's a lot of effort going into Rust right now. I will be surprised if it doesn't become the language of the 2020s. Because it really hits this nice point in the design space, but Haskell gives you maybe a cleaner experience, not having to worry about as much of the detail, and more essentially unlimited abstraction.
Yeah, and also our regular viewers know that I personally cannot implement breadth first search in Rust, but I can't do it in Haskell, so Haskell must be a little bit simpler. Anyway, so our next question is, okay, our next question is really passive aggressive. It goes like this: well, how do you explain monads to beginners? So
Um,
how?
yeah. um, the short version is not another monad tutorial, right? I think it's a stereotype for a reason. People understand it, then they have to go write the tutorial and explain to everybody how the thing works. Um, the I don't think that there's any shortcuts for monads, right? People need to get experience with them. The best way to start that is by saying, okay, well, this is a lot like, let's implement error handling. Let's show you some async code. Hey, it's interesting how you can use promises in JavaScript and then you have this async await thing. Isn't that interesting how those desugar into each other, right? And so people can then start bootstrapping up some understanding there, having them use the bind operator, right? And then having them do desugaring and resugaring, I guess, into do notation, just giving them some of those, like turn this into bind and turn this into do, and going back and forth like that, really helpful. And just getting them experience, this is how the point of a monad isn't the monad itself, right? It's the little languages that we can build with them and then snap them together, right? That's the benefit of these things. So just showing them a whole bunch of them, just like, async await versus promises, we can now apply that to a bunch of other things and write our own. And that helps. But again, there's really no shortcuts. You can't explain it over a coffee. They just haven't seen something like this before, and you have to learn by doing, I think.
Yeah, and in my opinion, if a person is studying Haskell specifically, then actually the approach from real world Haskell, when we look first at IO monad,
Mm-hmm.
and
Yeah.
kind of, because it's Haskell is really great. Like SPJ has this very short, almost a TikTok that is like Haskell is useless or something like that, where
Mm-hmm.
he speaks about, well, go watch it. I won't spoil it. But anyway, so Haskell, you can't with basic Haskell, right? You almost can't do anything, right? You can't print anything on the screen, and etc. So and and if a student is like stoic enough to tolerate the fact that Haskell is useless, then it's kind of inevitable for them to get into IO. And as a side effect, no pun intended, you can also tack onto it like a little bit more generalized notion, and maybe talk about the history of IO, how it was before IO monad, and kind of like unwrap the intuitions from there. But I completely agree with Brooklyn. No matter which technology you're using, you have to build up intuition here. You can't just like throw some definitions and then be like, oh well, that's it.
Yeah. And the other thing that I think is that we just haven't talked about in this context, and very few people talk about, is it's very you have somebody who often has a lot of experience already, and maybe in a different area of programming. They're a really fantastic Rubyist, let's say, right? And now they're trying something and they feel stupid for the first time in a long time. And having empathy with, it's okay, I felt like this too. It's fine, we'll get there, right? And you don't have to get this right away, right? We're going to do some exercises, and this is achievable. Helps a lot, because people get stuck in this loop of I must be an idiot, when
Oh yeah,
it's nothing could be further from the truth.
for sure. Yeah, and certainly,
Yeah,
yeah, as we briefly mentioned, like approaching this with as much of a beginner's mind as possible is
yeah.
absolutely crucial. And okay, final question is uh, again about Rust and Haskell. Speaking of Rust being really famous, isn't it very sad that Haskell is not becoming the next thing instead of Rust? What do you think?
Yes. Yeah, very sad, yes. And I think Rust will expose a lot more people to Haskell. I actually think that there will be a pipeline there, because it's really, in a lot of ways, it's what if you took C++ and Haskell and kind of smashed them together, right? In a lot of ways. And people will want to know where some of these things come from, or you'll have people saying like, but it's better in Haskell for these reasons, and then they'll go and explore it. Rust, I understand why it's getting the attention it is, which is fantastic, right? It hits this sweet spot in the design space. Even I remember reading Types and Programming Languages, I think has this in it, where they say like, like you could put a type system like this to do memory management and a bunch of things in an imperative language, but like we just haven't seen that yet, and here's Rust. So I understand why that's picking so much steam. I think Haskell has historically not invested enough in tooling and learning materials, and that is changing, right? The last couple of years, we have Haskell from First Principles. Nix is really exploding, and that has a lot of nice integrations with Haskell. The Haskell language server, really helpful, right? And plugging it in, not everybody's using Emacs, right? So plugging it into things that people are actually using and meeting users where they are, I think will help. I don't think that Haskell is going to get, that people will use only Rust and nothing else. I think it'll actually have the opposite effect. But I don't have a crystal ball. Who knows? We'll see.
Right. Yeah, I mean, I think that Haskell has a very bright future and even bright present. Like Haskell always, Haskell is alive still and very actively developed, and we, including Sorokel and Twig and a lot of companies are literally betting all our money on this technology. So I think it has bright future. And again, we have to remember the unofficial motto of Haskell, right? Avoid success at all costs. And this is kind of what we're doing, right? We're trying to be very precise and very kind of correct with everything we're doing. And we don't take engineering trade-offs lightly. I have so many examples of that effect, but we are running out of time. Actually, that's it for the questions from the audience. But I have one final question to you, Brooklyn. Mm-hmm. Vancouver is an overarching theme in your personal and professional story. What's so special about it? I know a lot of people who kind of moved around. Maybe they stayed in one place for a little bit, but for you it seems like that's your hub where everything happens. So can you tell us about your relationship with Vancouver?
Yeah, absolutely. Part of this is I moved to Vancouver in 2006. I took a few years traveling as a digital nomad in the middle there, but became a programmer here, have lived here essentially my entire adult life. It's a lovely city, has a good startup scene. It's a 2-hour flight from San Francisco. It's a short drive to Seattle, right? Like it's a nice hub to be. And a big part of why I was doing things, the Vancouver Functional Programming Meetup, things like that is, I wanted to have find other people that were passionate about these things that I could go get a coffee with and geek out, right? And that happened to then turn into some pretty foundational things for my life and my career. It is interesting that in this particular podcast, I guess, I've been talking so much about Vancouver. In 2017, 2018 or so, I made the decision of like, okay, well, Vancouver's great, lots of stuff is happening here, but what if I focused more internationally as well? And so spent a bunch of time in, had a home base here, but would spend a bunch of time in Berlin in particular, and then, traveling through Europe and running small events out there as well, and trying to create communities online, which is a very different flavor, right? So this distributed systems reading group, for example, right, which is online, participating in standards groups and trying to have an impact that are broader than the local community, which is fantastic. But there are now, it's set up and there's lots of people that can continue to run that. yeah, so the short version is it features so prominently because I'm based out of Vancouver, and one day we'll be able to keep traveling again. But yeah, it's the city's been very good to me, and the community's really fantastic out here. So I've been very lucky to be in a very beautiful place with lots of interesting people.
All right. Okay, then that's it for us for episode 5, also known as episode 1 of the functional features. And tune in next time. And thank you very much, Brooklyn, for coming to talk to us.
Great. Thank you so much for having me.